friends, welcome back to our channel Abhi Chemistry Tutorial. So in this video we are going to learn about Julia Olefination. So this is another topic in organic naming reactions. We have already posted few videos, few naming reactions in organic chemistry. You can check those videos. The links are given in the description box. The playlists are given in the description box. You can also view this video in English and also in Tamil also. So we are going to learn about an organic naming reaction which follows through a carbanion intermediate in this video, and this is Julia Olefination. So before going into the video, I'll show you a photo on the screen. You can see most of the viewers have not subscribed to our channel yet. So please take a second to subscribe to our channel, share to your friends. So now let's get started. Julia Olefination. It is also called Julia Lythgol Olefination. So what is Julia Olefination? It is the reaction between phenyl sulfones and an aldehyde or ketone. The final product we get will be an alkene. So this is named after a French chemist, Mary Julia. So here you can see this reaction. This is a phenyl sulfone. So this is a sulfone compound SO2. The compounds containing SO2 are called sulfone compounds, and here you have phenyl, so phenyl sulfone. It is subjected to react with few compounds, N-butyl lithium and an aldehyde and an alkyl halide. You get an intermediate, an alkoxide, and finally when you subject to sodium amalgam reduction and ethanol, you finally get an alkene. So this Julia Olefination most probably favors the formation of trans-alkene. So here you can see the alkyl groups are present in the trans positions of this double bond. So R1 is present here and R2 is present in this position. So this Julia Olefination favors trans-alkene. So this Julia Olefination takes place in 5 steps, and the usage of this R3X, that is an alkyl halide usage, is optional. So now let's learn the mechanism. So it takes place in 5 steps, and the first step is the abstraction of proton from the phenyl sulfone to form a carbanion intermediate. So here you can see this is the phenyl sulfone. So the first alkyl group is represented by R1 and phenyl group here. So first we are subjecting to reaction with N-butyl lithium. So abstraction of protons. So here in this carbon you will have 2 hydrogens. So one hydrogen will be abstracted as H+. So this butyl lithium abstracts one proton to form a carbanion at this position. So this H+ is lost. So this carbon will have the negative charge. So this is called a phenyl sulfone anion. Then this is the first step. Step 2. So step 2 is the reaction of the formed carbanion with aldehyde to form an alkoxide. So this is the carbanion we got in the first step, and here we have the aldehyde with the alkyl group, second alkyl group R2. Here you can see we have a double bond here, and this bond is shifted over this oxygen to form a negative bond over this negative charge over this oxygen, and now the carbon will gain a positive charge. And this minus or this carbanion gets attached to this carbon atom, and you get a bond here in between this carbon and the carbon of this aldehyde. So here you can see the same compound, carbon, carbon, oxygen O minus, H and R2, same as in the aldehyde. So this is an alkoxide. Step 3. So this alkoxide reacts with an alkyl halide to form a stable intermediate. So here you can see, so this alkoxide is reacted with this alkyl halide. So you know when this alkyl halide splits, you get R plus and X minus. So this R plus goes with this oxygen to form a bond. So OR3, as you can see here. So this is a stable intermediate. Step 4. Sodium amalgam reduction takes place with the stable intermediate. So this is the stable intermediate, and sodium amalgam reduction takes place to form the vinyl radical. As you can see here, this phenyl sulfone group is removed to form a radical at this carbon. This OR3 is also removed to shift this bond over here to form a double bond between these two carbon atoms, and this is a vinyl radical. So step 5 is the protonation of the vinyl radical. So you can see this is the vinyl radical, and again we are adding ethyl alcohol. So in this case, protonation occurs at this place and we get an alkene here. So this is the final product of the Julia Olefination. So this is all about Julia Olefination. So I hope this video is useful for you. So please like this video, share to your friends, and don't forget to subscribe to our channel and keep waiting until I upload the next video. See you all in the next video. Until then, bye. Thank you. Take care.